Hi guys, I just wanted to do a quick video on the difference between sector length and sector area. Sector length is this part over here, like the crust of a slice, and the formula to that comes from the circumference of a circle, which the circumference is the whole part around. It's 2 pi r, or the circumference could be called pi times diameter, which the diameter would be the whole line across, right? That would be the diameter, where this is the radius, right? So the sector length formula is either n over 360 degrees times 2 pi r, or n over 360 degrees times pi times diameter, but that's only if n is in in degrees. If you happen to want to do it where n is in radians, if n is in radians, okay, that's the other unit measure, then the sector length formula is really easy. It's just n times r. Okay, that's a really nice thing when it's radians. You just multiply the angle with the radius, and that will give you the length. Okay, now let's take a look on the other side. The area of a circle is pi r squared, so the area of a sector is going to be n over 360 times pi r squared. That's where that comes from. There is one with the radians, but we don't really use it. I mean, you can use it, but I'm not like really such a big fan. I would stick to these. This one or this other one over there also is good. Okay, the one that is, if it is in radians, so I'll just make it like a smaller, like less in your face color. So if radians for n, then you can say area of a sector is n over 180 r squared. But like I said, not super popular. Now I'm going to go into some examples. So here's a problem I'm giving you where they give you these angles and they're given in radians, and they're going to ask you to find the length, determine the length of CAB. Arc CAB. Arc is symbolized the little arc symbol on top. So they want this whole part going around this way. And the angles are given in two little pieces. So and they're given in radians. So there's two ways to do this. The first thing I can do, one way to do this is add them up. Obviously, you'll have to do that any way you look at it. Pi over 6 plus 2 pi over 3. And of course, they need a common denominator. So I can write this as pi over 6 plus 4 pi over 6, which is the same as 5 pi over 6. Okay? And so if I use the formula sector length, and I say it's the angle times the radius, then my sector length is going to be 5 pi over 6 because I'm using radians, and then 10. So I get my sector length to be 50 over 6, or 25 over 3 pi, and that is in feet. And let's say it says to leave in terms of pi, that would be it, or you just put in your calculator if they tell you to round. Another method to do this, I'll use a different color. Another method is you add them, or you find what each angle is. So maybe convert to degrees if you prefer. And reviewing how to convert to degrees, what you want goes on top. So if you go pi over 6 and you do 180 over pi, that would mean that this is going to be 30 degrees. And if you take the other one, which is 2 pi over 3, and you do 180 over pi, and you cancel those, then you're going to get 120 degrees, right? Because, right, 180 over 3 is 60 times 2 is 120. That's a 20. And if you add these two up, then that's going to be 150 degrees. So you could have added them as fractions first, then converted. It doesn't really matter. So now that you're in degree formula, your sector length formula has to be n over, you have to use degrees, 360 degrees times 2 pi r, or pi times diameter. It doesn't really matter. So your sector length is, we have 150 degrees over 360 times 2 pi, and the radius is 10. So sector length is, if I simplify this, that's times 20 and work it out, I am going to get 25 over 3 pi feet. And so there you have it, 2 ways that you are using the sector length. Now let's look into area. So let's say you're given this problem where they give you the area and they're asking you to figure out what the radius is. So you're going to use your formula for the area of a sector, which is n over 360 pi r squared. And since that's the area given to you, you're going to put that in on the left, and that's equal to, and they give you the angle, so that goes right there, 360 pi, and then the radius, well, that's what we don't know, so I'm just calling that x. All right, you can simplify first if you want to. I do believe it helps, and 30 over 360 reduces to 1 over 12 pi x squared, and then this is 16 pi over 3. Now you got to get x by itself. So there are some tricks. Since you have pi on both sides, you can cancel them out because you divide both sides by pi. That's what you get. So if you can jump on that, go ahead and do that. And then x squared. Now I see the fraction 1 over 12, even if it wasn't a 1. What I like to do is I like to multiply by the reciprocal, which is 12 over 1. Could have just multiplied by 12, but I just, in case there was a number there, you could also do that too. So you end up with x squared is equal to, and this is 1 and this is 4, so that's 64. So x is equal to, when you take the square root of both sides, you're going to get x is equal to 8. So the radius, and don't forget the units, is equal to 8 inches. All right. Hey guys, I hope this helped. Sorry it took me so long to get it to you, but all in all, I hope it helped. Here's that, and that. Be well and stay warm.